So here is my 12-volt power supply made out of random junk, finally completed. This is just part of an old PC power supply. The steel box is part of an outdoor phone box of some sort. On the inside we have a large variac, I guess a 5 amp variac. I'm not quite sure. No, 10 amp, I believe. And let's see. Well, it is as it is. I have a 20 ohm resistor here, 25 watts, so it should be able to take 1 amp indefinitely. So I'm just going to turn it on here. Demonstration. Light comes on, that's the power light. And then I can turn the voltage up here. If I turn it up to about full, let's put it on 19 volts. It won't quite go all the way up to 20 volts, and I have no problem with that. Let's see, it's getting a little warm. So that's about 25 watts, but it's actually rated for that, so it could continue. Now, this uses a amperage limit circuit, which is over here. I can turn down the amps allowed, and of course the only way to reduce amps is to reduce volts if you have a fixed resistance here. So that's what happens. Turning this further down causes volts to drop until you basically are driving the load with a current source. So you can set the current to whatever you want. This will be more obvious when I see there. I've actually turned the allowed current down to almost zero, so the voltage pretty much goes away. But without limiting the current, it pretty much produces whatever voltage you dial in here. So, and let's see, accuracy. If I set the meter to what looks like 19 volts, then over here on my precision meter, I have 18.98 volts. That's close enough for me. So let me see. Let me turn this off now. Then over here, I have this is about 1/3 of an ohm at room temperature, of course. If it gets hot, it goes up in resistance a little bit. So I can use this as a test load also. This is the test load that actually burned it out the first time. My first burnout. I was so pleased to get a truly legendary burnout. However, there was no smoke. It just died. It just sort of became pathetic and died. So let's see here. Turning the voltage up. 1/3 of a ohm means that at about, I get about 6 amps if I produce about 2 volts. And sure enough, there is 1.94 volts, and the meter claims we're getting 6 amps. So that's about right. And it's getting warm, not real hot. I can turn this up a little bit higher. Let's put 10 amps through it. Whee! And okay, now this is starting to get warm here. And this is definitely getting warm. You could put a beaker of tea there and keep your tea warm just using this. In fact, that's not a bad idea, to make a tea warmer out of just a piece of cut PC board like this. Maybe not too efficient, but anyway, that's pretty much all I want to demonstrate Again, I can turn the current down to whatever I want here. The amps limit signal comes on here, indicating that we're operating as a current source that's controlled by this knob, and etc. So, yay. Now, when it gets really, really blazing hot, if I run it at like 10 amps for a long time, then the temperature warning light comes on and voltage starts dropping again. So this will drop right down to 0 when the temperature warning comes on. And when it cools off, it will gradually turn itself on again. But I don't want to demonstrate that right now. Take my word for it. It works. So that's it. Project finished, and it only took a year. Well, there was a very long hiatus, but what can you expect? I got distracted. So that's it for this project. Thanks for watching the video, and I'll catch you another time in the future.